Here we have a SAT math problem. Okay, let's go to the question. If 2 to the x power equals to 4 to the y power equals to 8 to the z power and 1 over 2x positive 1 over 4y positive 1 over 4z equals to 4, then the value of x is. Okay, using these two equations, we have to solve for x. Okay, now let me take the first equation, that is 2 to the x power equals to 4 to the y power equals to 8 to the z power. Okay, we can write this 2 to the x power as it is, and here this 4 is a power of 2, that is this 4 can be written as 2 square, that is 2 square equals to 4, and since we have y as the exponent for this 4, the same exponent y can be taken over here, and this 8 is also a power of 2, that is 8 can be written as 2 to the third power, that is the value of 2 to the third power equals to 8, and since we have exponent z over here, the same exponent can be taken for 2 to the third power. Okay, here we have 2 to the x power, and here we have the base 2 and we have exponent 2, and for this complete stuff we have the exponent y. Whenever we have two exponents like this, we can multiply the two exponents using the power of a power rule in exponents. Then we get 2 to the power of, we can multiply these two exponents 2 and y, then we get 2 times y is just 2y. So the same thing we can do over here, that is we can multiply the two exponents c and z, then I'm getting 2 to the power of 3z. Okay, here 3 terms are equal with the same base 2. Okay, whenever 2 or more terms are equal with the same base, we can equate the exponents. So then I'm getting x equals to 2y equals to 3z. That is, I equated the exponents, all the three exponents over here. Okay, here x, 2y and 3z, all of them are equal. For example, if I assume 5 as the value of x, then what is the value of 2y? So the value of 2y is also 5, the value of 3z is also 5, because all of them are equal. But I do not know exactly what's the value of x. Actually, that's what I have to find. Okay, let me assume k as the value of x. Then what is the value of 2y? So for 2y also we have the same value, that is k, and for 3z also we have the same value, k. So let me assume all these three quantities are equal to k. Since all of them are equal and all of them are equal to k, we can equate each quantity to the constant k. Then we get x equals to k, 2y equals to k, and 3z equals to k. Okay, here the first one is already solved for x. Now let's solve for y in this equation. For that we have to divide both sides of this equation by 2. Then this 2 will cancel. I am getting y equals to k over 2. And let's solve for z in this equation. For that we have to divide both sides by 3. Then this 3 will cancel. I am getting z equals to k over 3. Okay, now I got the values for x, y and z in terms of k. Now what we can do is we can plug in these values for x, y and z into the second equation we have over here. Okay, now let me take the second equation as it is. That is 1 over 2x positive, 1 over 4y positive, 1 over 4z equals to 4. Okay, here 1 over 2 times. So for x we can plug in k. That is 1 over 2k positive 1 over 4 times. For this y we can plug in k over 2. Let me do it. 4 times k over 2 positive 1 over 4 times. For z we can plug in k over 3. Let me plug in equals to 4. Okay, here 2 goes into 2 1 times and 2 goes into 4 2 times. We get 1 over 2k positive, 1 over 2k positive, and here we have 1 over 4k over 3. So we can write this 1 as it is, and we can change this division as multiplication. When I change this division as multiplication, I have to get reciprocal for this one. So the reciprocal of 4k over 3 is just 3 over 4k equals to 4. Here we have addition of two fractions with the same denominator 2k. So we can take this 2k as a common denominator and we can add the numerators. That is 1 positive 1 over 2k, positive 1 times 3 is 3, that is 3 over 4k equals to 4. Okay, here 1 positive 1 is 1, that is 2 over 2k positive 3 over 4k equals to 4. Okay, now to add these two fractions, we need the same denominator. Here we have the denominator 2k in the first fraction. The second fraction we have 4k. So to get the same denominator for both the fractions, I multiply both numerator and denominator of the first fraction by 2. So when I do so, 2 times 2 is 4 and 2 times 2k is 4k. That is, I am getting 4 over 4k positive 3 over 4k equals to 4. Okay, now we have addition of two fractions with the same denominator 4k. So we can take the denominator 4k as a common denominator and we can add the numerators of 4 and 3. That is, we get 4 positive 3 numerator. On the right side we have 4. Okay, 4 positive 3 is 7. That is 7 over 4k equals to 4. Okay, my aim is to solve for k because k is the value of x. Okay, when I get the value of k, that can be considered as a value of x, that is our target. Okay, to solve for k, we need this k in numerator, but it's in denominator. So for that, what I can do is I can take reciprocal on both sides. When I take reciprocal for the 7 over 4k, I am getting 4k over 7. On the right side also, I must take reciprocal because I have taken reciprocal on the left side. Okay, when I take reciprocal for this 4, I am getting 1/4. Okay, since I have to solve for k, I have to get rid of this fraction 4 over 7 here. So to get rid of this fraction 4 over 7, I have to multiply both sides of the equation by the reciprocal of this fraction, that is 7 over 4. Okay, let me do the same thing on the right side as well. So here this 4 will cancel, 7 will cancel. I'm just getting k on the left side. On the right side, 1 times 7 is 7 and 4 times 4 is 16. Okay, now I got the value of k. As I said earlier, k equals to x. So since k equals to x, we can replace this k by x, then we get x equals to 7 over 16. Okay, I got the value of x. The value of x is 7 over 16, and we find this 7 over 16 in answer choice D. The correct answer choice for this question is D.